GenAI and MLOps Part 3. This episode has 10 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. MLflow. MLflow troubleshooting. An MLflow run logged metrics but the model artifact is missing or cannot be loaded. How would you debug it? Here's a strong way to approach it. Check whether the run completed the artifact logging step. Inspect the artifact URI. Verify the tracking server and client are using the same artifact store configuration. And confirm the service account or user has write or read permissions to the bucket or file system. Then verify dependency or environment files, model flavor, serialization format, and MLflow version compatibility, because a model can exist in storage but still fail to load if the environment or flavor metadata is wrong. Nice. Let's continue. Question 2. Python. Mach 49 focus. Python concurrency and multiprocessing choices for cloud and ML workloads. When would you use threads, Asyncio, multiprocessing, or a bounded worker pool? Here's a strong way to approach it. Use threads or Asyncio for I or O bound work such as cloud API inventory, object store reads, HTTP calls, and database queries. Use a bounded worker pool when you need concurrency but must control API quota, memory, or downstream load. Use multiprocessing for CPU-bound work such as feature computation, PDF or image parsing, model pre-processing, compression, encryption, or large local transformations, because separate processes can use multiple CPU cores and avoid the GIL. In production, the decision should come after profiling, and every concurrent design needs timeouts, retries, error collection, and rate limits. Great. Moving on. Question 3. Python. Mach 49 focus. Python multiprocessing deep dive. Explain multiprocessing in Python and when it is better than multithreading for CPU-heavy ML or data processing tasks. Here's a strong way to approach it. Multiprocessing creates separate OS processes, so each worker has its own Python interpreter and memory space that lets CPU-heavy Python code run across multiple cores without being limited by the GIL. It is better than multithreading for CPU-bound work such as feature engineering, image or PDF parsing, CPU-heavy pre-processing, encryption, compression, and batch scoring transformations. Threads are usually better for I or O bound work because they are lighter and can overlap waiting on network or disk. The trade-offs of multiprocessing are process startup cost, memory overhead, serialization or pickling of data, and more careful handling of shared state through queues, pools, shared memory, or external storage. Alright, next question. Question 4. RAG. Mach 49 focus. RAG reliability debugging. A retrieval-augmented generation pipeline returns stale or irrelevant context. How would you debug indexing, embeddings, chunking, retrieval, and re-ranking? Here's a strong way to approach it. First, classify the failure. Stale context means the source-to-index pipeline is behind. Irrelevant context means retrieval quality is poor. For stale results, check source update time, ingestion jobs, failed upserts or deletes, index aliases, and whether the right collection is queried. For irrelevant results, inspect chunk size, overlap, metadata filters, embedding model or version mismatch, query rewriting, top K, similarity threshold, and re-ranker behavior. Validate with a golden retrieval set where each question has expected source documents, log retrieved IDs, scores, chunk metadata, and prompt template versions so every bad answer can be traced to retrieval or generation. Let's keep going. Question 5. RAG. Vector database operations. How would you operate a production vector database, including indexing strategy, re-indexing without downtime, backup or restore, and scaling for query latency? Here's a strong way to approach it. Choose an index type, HNSW for low latency approximate search, IVF for larger scale with a recall or speed trade-off, sized for expected vector count and query rate, and re-index without downtime by building the new index alongside the old one, blue-green, and cutting over traffic once the new index passes recall or latency validation. Back up the underlying vector store and metadata together so a restore reconstructs a consistent state, and scale query latency with read replicas, sharding by tenant or namespace, and caching frequent queries. On to the next one. Question 6. RAG versus fine-tuning versus prompting. How would you decide between prompt engineering, RAG, and fine-tuning for a domain-specific GenAI use case? And how would that decision change operational ownership? Here's a strong way to approach it. Start with prompt engineering for anything that can be solved with better instructions and few-shot examples, since it has the lowest operational cost and fastest iteration. Add RAG when the model needs access to specific, frequently changing, or proprietary knowledge it wasn't trained on. Reserve fine-tuning for cases needing a consistent style or formatted scale or behavior that prompting genuinely cannot achieve, since fine-tuning adds real operational ownership. Training pipelines, versioned model artifacts, evaluation before each retrain, and a rollback story that prompting and RAG don't require. Good. Here's another one. Question 7. RAG. Resume deep dive. RAG pipeline. Walk me through the RAG pipeline you built, including embedding model choice, vector database, chunking, and how you measured answer quality. Here's a strong way to approach it. The pipeline chunks source documents with an overlap strategy, typically 200-500 tokens per chunk with some overlap to preserve context across boundaries, embeds chunks with a domain-appropriate embedding model, and stores vectors with metadata for filtering. At query time it embeds the user question, retrieves the top k most similar chunks, and passes them as grounding context to the LLM. Answer quality was measured with a mix of retrieval metrics, recall at k against a labeled set, and generation metrics, groundedness or faithfulness checks, either via an LLM as judge or human review, rather than relying on generation quality alone. Nice. Let's continue. Question 8. MLOps architecture. Kubeflow versus MLflow versus Vertex AI. How would you choose between Kubeflow, MLflow, and Vertex AI for a GCP MLOps platform? Here's a strong way to approach it. Use Kubeflow when you want Kubernetes native control over pipelines, training, serving, and multi-user ML workflows, especially on GKE. Use MLflow when experiment tracking, model packaging, and registry portability are the primary needs. Use Vertex AI when managed GCP operations, IAM or audit integration, managed endpoints, and lower platform maintenance matter most. Many real platforms combine them, for example Kubeflow for pipelines, MLflow for tracking, and Vertex AI for managed serving. Great. Moving on. Question 9. GenAI observability. Mach 49 focus. RAG and LLM observability. What would you trace and log end-to-end for a RAG request without leaking prompts, PI, secrets, or retrieved sensitive text? Here's a strong way to approach it. Trace the full request path, gateway, auth, query rewrite, vector search, re-ranking, prompt assembly, model inference, tool calls, and response post-processing. Log safe metadata such as trace ID, tenant, prompt template version, model version, retrieved document IDs, chunk IDs, similarity scores, token counts, latency by stage, cache hit or miss, finish reason, and safety flags. Do not log raw prompts, secrets, PI, or full retrieved content into standard logs. If deep debugging payloads are required, store redacted or access-controlled samples with short retention and clear audit trails. This gives enough signal for latency, cost, hallucination, and retrieval debugging without creating a data leak risk. Alright, next question. Question 10. LLM architecture. Mach 50 focus. LLM production architecture. How would you design a production LLM-backed service with model routing, caching, rate limits, observability, safety, and cost controls? Here's a strong way to approach it. Design it as a normal production service plus LLM-specific controls. Put an API gateway in front for auth, quotas, request validation, and tenant identification. Route requests by use case to the right model. Cheap or fast model for simple tasks. Stronger model for complex tasks. Fallback model for provider failures. And self-hosted model where privacy or cost requires it. Add caching for repeated deterministic prompts. Token budgets per team. Prompt or template versioning. Safety filters. And guardrails around tool calls. Observability should capture trace ID, model version, prompt template version, token count, latency by stage, retrieval metadata, error type, and cost without logging sensitive raw prompts. Let's keep going. That wraps up this episode. Nice work practicing, and see you in the next one.